With the class, we'll be discussing Pythagoras theorem under trigonometry. Pythagoras theorem. Who is Pythagoras? Pythagoras was a mathematician and a philosopher who worked rigorously on the concept of trigonometry. He postulated a theorem, and the theorem is what we want to discuss this afternoon. Pythagoras theorem. What does this theorem state? Pythagoras theorem states that the square of hypotenuse side of a right angled triangle equals the sum of the squares of the opposite side and the adjacent side. What are we saying? This is a right angled triangle labeled angle A, angle B, and angle C. Now, in a right angle triangle, the sum of the angles in a right angle triangle amounts to 180 degrees. How? This particular side, which we refer to as the right angled, as in what makes it to be right angled is this side, and it is 90 degrees. These two other particular angles, this one and this one, the sum is 90 degrees as well. And if, for instance, we say this is theta, which is a particular angle less than 90 degrees, as you can see, it's an acute angle. Now, and we say that the sum of angles in a triangle is 180 degrees. If this is an angle that is less than 90 degrees, and this is 90 degrees, it definitely means the angle here will also be less than 90 degrees. What does that mean? It means that if this angle is less than 90 degrees, and this is less than 90 degrees, and this is equal to 90 degrees, the sum of these two angles will be 90 degrees, and this is 90 degrees, in which the total sum of the angles in this right angle triangle will end up amounting to 180 degrees. Now, what are we saying? This brings up another concept which we call complementary angles. What are complementary angles? Complementary angles are angles that sum up to 90 degrees. Complementary angles. For example, as we have theta here, for this to be 90 degrees, we must say that this particular angle must sum up with our angle here that will be 90 degrees minus theta. And if we sum it up, we will definitely have 90 degrees. Theta plus 90 degrees minus theta. Theta minus theta is gone. We are left with 90 degrees. So if we add this 90 degree with 90 degrees here, we'll see that the sum of the angles in this triangle is 180 degrees. I think that is clear. Now let's go to the Pythagoras theorem clearly. In Pythagoras theorem, we mention three words. What are those words? Hypotenuse, opposite, and adjacent. What is hypotenuse in a right angle triangle? What is opposite? What is adjacent? Now, as this triangle is drawn, this right angle triangle, the longest of its sides, we have three sides, this side, this side, and this side. The longest of these three sides, which by mere looking at it, this is the longest of the side. The longest of the sides is what we call the hypotenuse. Hypotenuse. Okay? Now, this is an angle here. For instance, for example, if we decided that this is the angle that we want to make use of, this angle is facing the side. The side this angle is facing is what we refer to as the opposite side. Opposite. And the side where the angle lies is what we refer to as the adjacent side. Adjacent side. So where the angle lies, angle theta, where it lies is called the adjacent. Where the angle theta faces is called the opposite. The longest of the sides of the right angle triangle is what we refer to as hypotenuse. Now, the theorem. The theorem says that hypotenuse square equals the sum of squares of opposites and adjacent. And we've explained when we were discussing trigonometry in our class that metric is a measure of distance. And this measure is a function of non-negative real number. So it means that all these distances that we have, the side, they are measure of distance. They are measure of distance, and they must be positive. They must not be negative number. They must be positive. And this is what will bring us to the formula of Pythagoras theorem. As we've said earlier, hypotenuse, we have absolute value there because they must be positive. Distance, measure of distance. We have square equals the sum of squares of opposite and adjacent. Opposite squared, absolute value because it must be positive, then adjacent square. Adjacent square. That is the formula. Now, let's make use of this right angle triangle as we've been using. If this is angle A, as I've stated, this is angle B, this is angle C. Where this angle faces, let's label this side, this adjacent side, side A, side small a, and this side, the longest of the sides, let's label it side C, and the opposites as with respect to the angle theta is the side, and let's label the side B. Now we've known the sides, the three sides, side A, side B, side C, and we've known the three angles: angle A, which is 90 degrees minus theta, angle B, which is theta, and angle C, which is 90 degrees. Now, with respect to this right angle triangle, we can have that our side C, which is the same thing as hypotenuse squared, of course, is positive. Even if C is negative, once it is squared, it becomes positive. But C is never negative, it's positive because it's a measure of distance. We have C squared equals opposite side, the side B, B squared, adjacent, which is the side A squared. And this is also the formula for Pythagoras theorem. In other way, if we do not want to use the small letters, we can use the capital letter. Side C we can also say it is side AB. Instead of using side C, we can also say side AB. Side AB squared. Okay, let's use the upper part of the board for easy visibility. We can say side C, which is the same thing as AB, absolute value squared, equals B squared, B side AC squared plus A squared, which is side BC squared. This is Pythagoras theorem as stated. Now, we want to solve a question with this theorem, and this is where we must be attentive. We have to listen properly here and we must take something good out of it. Now let's look at a particular question where we are given all the three sides of the right angle triangle and we have to find a particular unknown. Let me use this example. We have a right angle triangle. Okay, we're given the side to be x, and we have the side to be x plus 1, and we have this side to be x plus 2. For instance, let's say the angle is labeled here theta. Now, we want to find the value of x. What is the value of x? Don't forget, I said something the other time that in Pythagoras Theorem, the sides of the right angle triangle are measure of distance, and they must be positive. They must be positive. We must not have a negative number there. So it means that whenever we are calculating for x, the value of x2 must be positive. Now let's go with the theorem. Hypotenuse. It is clear that the longest of the sides here is this side, which is x plus 2. We have x plus 2 hypotenuse squared as x plus 2. This side is the hypotenuse. Let's label it for proper clarity. Let's still say A, and let's call this B, and let's call this C, and this is our angle theta. Now, hypotenuse squared, x plus 2 squared, equals opposite squared, x squared, plus adjacent squared. We have x plus 1 squared. Now, we have to open the bracket to make it clearer enough for us to understand. This is squared. Squared means something that is multiplied twice. Multiplied twice. So it means this is x plus 2, x plus 2, that is multiplied twice, equals x squared plus, same thing here, x plus 1, x plus 1, multiplied twice. Now, having done this, we open this bracket. Okay, I haven't opened the bracket from here. I did this for us to understand what this squared means. If we had gotten 3 here, we are going to multiply it 3 times. 3 times. But here, we have in square, it means it's going to be multiplied twice. So 2 times. Now let me open the bracket now for proper clarity. There's a concept in mathematics where we have multiplication is distributive over addition. Multiplication is distributive over addition. So here, we take x, we use it in multiplying the whole of this sum, x plus 2. And we take plus 2 also, we use it to multiply this bracket x plus 2. And that is how we use for multiplication that has two factors. Like we are multiplying 2 things together. This is a factor, this is another factor. We take each of the term in those factors to multiply the other bracket. What are we saying? This is what we are saying. We take x in bracket, the whole of this, what we have here, x plus 2. We close it. We also take this other term, which is plus 2. We multiply it by what we have here, the same thing, x plus 2. Okay, so from there, we have equal to x squared plus, we also do the same thing here. We have x, we use it to multiply the whole of x plus 1. We have x plus 1. We take plus 1 again. We use it to multiply the whole of x plus 1. We have x plus 1. Now from there, we can open this bracket. X times x, we have x squared plus x times 2, we have 2x plus 2 times x, we have 2x plus 2 times plus 2, we have plus 4 equals, this is x squared, we put it down. We also open this bracket, x times x, we have x squared plus x times plus 1. We have plus x plus 1 times x. We have plus x plus 1 times 1. We have plus 1. Now, from here, we can collect like terms. We can collect like terms. Now, let's collect like terms from here. We have x squared in the right hand side of the equation. We have x squared here in the left, we have x squared in the left hand side of the equation. We also have x squared in the right hand side of the equation. Now, let's sum up what we think we can collect together. Let's collect like terms. This is alike with this and this. If we sum up x squared that is here with this, x squared plus x squared here, we have 2x squared. We can have x squared, but having summed up the x squared and x squared here, that we have plus 2x squared, and taken to the other side of the equation, it gives minus 2x squared. Instead of wasting much of our time to expand it again, we can easily bring it like that. So we have x squared minus 2x squared. That is x squared plus x squared, which is 2x squared. Because we've taken it to the other side of the equation, it becomes minus 2x squared, and that is the minus 2x squared here. Now, we are done with all the x squared. We have collected all the x squared that are alike. Now we have x. We collect that also. Plus 2x plus 2x. We have plus 4x. Plus 4x. Also, we have plus x here. That is plus 2x. When this plus 2x is taken to the other side of the equation, it becomes minus 2x. So we have minus 2x. I think we have collected all the x's too. We have the constant value. We have plus 4 here. We have plus 1 here. This is plus 4. If this 1 is transferred to the other side of the equation, it becomes minus 1. Then minus 1. Then there is nothing here because we've taken everything here to the other side of the equation. Then this place becomes 0. Okay, then we collect like terms again because we can see some things that are like here again. So x squared minus 2x squared, we have minus x squared. Plus 4x minus 2x, we have plus 2x. Plus 4 minus 3, we have plus 3. Plus 4x minus 2x, we have plus 2x. Plus 4 minus 3, we have plus 3 equals 0. We have to be careful with our dealings with our subtraction and addition because it can lead to a slight mistake. And once there is a mistake in plus and addition, there is a high tendency that your answer will be wrong. So from here, let's solve it. Or since we have an x here, the x here is negative, we can use as a principle of dividing all through by minus or multiplying all through by minus. Anyone, you still have the same thing. Or you can also use another principle by bringing the whole of all of these to the other side. Then their sign changes. Everything is still intact. So let's use multiply all through. Multiply all through by minus 1. So if we multiply all through by minus 1, we have this to be minus x squared minus 1 plus 2x minus 1 plus 3 minus 1 equals 0. So this is x squared plus minus 1 times plus 2x. That is minus 2x, and that is minus 3 as well, equals to 0. Now, what are we going to have here that will give us minus 2 and minus 3 here? If I have the sum of minus 3 plus 1, minus 3 plus 1 will give me minus 2, because this is actually a quadratic equation. And in a quadratic equation, we have this first term, second term, and the third term of the equation. This second term is always referred to as the sum, and the last term is the product. Now, one of the methods used in solving a quadratic equation is factorization method. To factorize, we look at the two numbers. When we add them together, we have the sum, we have this minus 2, and when we multiply those two numbers by, if we multiply one of them by the other, we have this product, minus 3. And it is not far-fetched. Minus 3 plus 1, if we choose minus 3 plus 1, let's say by factorization, let's use this place for clarity. By factorization method, we have x squared plus, this is minus, we have chosen minus 3 plus 1, minus 3x plus x. Those are the two factors, because minus 3 plus 1 is minus 2, and minus 3 times 1 is minus 3. So minus 3x plus x, which is minus 3 plus 1, those are the two factors, two numbers that we have chosen. Then minus 3 equals to 0. Then we have x, we factorize this, or we bring them together. Let's bring this to this place. We have x squared plus x, we are just rearranging, nothing is changing, we are just rearranging. Minus 3x minus 3 equals 0. So we have x here, want to factorize now. X times x, we have x squared plus 1, which is this plus x, minus 3x plus 1 equals 0. We still have not changed anything. Here we have x in bracket x plus 1 minus 3 in bracket x plus 1 equals 0. So we have, when we multiply these together, we still have x squared, x plus 1, x times plus 1, we have x, minus 3 times x, we have minus 3x, minus 3 times plus 1, we have minus 3 equals 0. Now, what we want to do here is that if we observe something in this particular equation that we've written, we will discover that this first bracket contains the same term with what we have in the second bracket. Of course, having got that, we are near to our conclusion. We take one of those terms in these two brackets and those terms in the outside, as in outside of the bracket. So what we have in the bracket and what we have outside of the bracket. So we have x minus 3 outside of the bracket, and we have x plus 1 in the bracket. That is x plus 1 equals 0. Now, these are the factors. Then we split them. We have x minus 3 equals 0, or x plus 1 equals 0. Now, we write our individual result. X equals 3, because when 3, which is at the left hand side of the equation, goes, if it's minus 3, this is minus 3. When it goes to the right hand side of the equation, the sign changes to plus, and that is why we have an x equals to 3. Or x, this is plus 1 in the left hand side. When the plus 1 goes to the right hand side, the sign also changes to minus 1, and this is 0. It doesn't affect it. So we have x equals to minus 1. Now, I said something about metric the other time, and we are dealing with distance, length, distance. And of course, we have to result for x, and because the question asks us to find the value of x. Which of the two results will be our final answer? It definitely, without doubt, that 3 will definitely be our result, and this one is not the determined or predetermined result, as it is negative, because what we need is a non-negative real number. So these are the ways which we can apply Pythagoras theorem in solving questions. In fact, there are some other questions which we can apply it to rhombus, to chord, many as possible. So Pythagoras theorem is very useful, is a useful tool in mathematics. This is where we're going to end this class. I enjoin you to subscribe to our channel, like and share. Thanks for watching. We appreciate it.